All right, let's take a look at question 30. Question 30 from the 2024 Advanced Maths paper. This is quite a weirdly structured question. It's a question about geometric series. These can get quite challenging. They also give us information about a graph. We don't necessarily need to use that though. So let's think about this geometric series we're given. We're told that x plus x squared plus x cubed plus dot 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 has a limiting sum s. Well, if it has a limiting sum, this actually implies that it has infinitely many terms, but the multiplication factor between the terms is less than 1, the absolute value of it. So the first term in this series is x. Multiplication factor r is x, with the condition that the absolute value of x must be less than 1. So this tells us that x is included in the set -1 up to 1. Not including -1 or 1. We have a formula for this. So the limiting sum s in the case of a geometric series is a over 1 minus r. A is x, r is x, so this is x over 1 minus x. Now this is the point where we could choose to draw this function or the function given in the question, right? They're pretty much the same thing. We don't really need to, right? We can just do this algebraically. So given that the sum, the limiting sum, is equal to x over 1 minus x, really all we need to think about is the endpoints of the x values that we could have. So we could have something approaching -1, and this would be approaching from the right. So approaching -1 from the right. We could also have something approaching 1 from the left. If we have a value, an x value, that's getting smaller and smaller and smaller, the limiting sum will become essentially -1 on 1 minus 1, which will be -1/2. So as x approaches -1 from the right, the limiting sum approaches -1/2. Now, the -1/2 value itself is not actually viable, because if x is -1, which it's not allowed to be, but if it was, then the sequence, the series would be -1 plus 1 -1 plus 1, and that doesn't really have a limiting sum in the conventional sense. So you could get limiting sums as low as -1/2, but just above -1/2, not including the -1/2. On the other end of the spectrum, as you approach 1 from the left, you find that the sum is essentially 1 over 1 minus 1. This is 1 over 0. This is undefined, so you can't really just sub it in. But if you plug in values that get closer and closer and closer to 1, you'll find that this grows sort of infinitely, right? It gets higher and higher and higher. So as x approaches 1, we find as x from the left approaches 1, then we get that the series approaches positive infinity. So these are the two bounds on the sums. So the sums, therefore, are included in the set -1/2 all the way up to positive infinity. And this is in fact the solution. Now this works because the sum function x over 1 minus x that we got is actually a continuous function. Between -1 and 1. It has a pole at 1, but between -1 and 1, not including those points, it's continuous. It's in fact a type of hyperbola, right? So if you drew the function they gave you here, you would get -1. So this is we'll just rewrite the function they gave us here quickly. Y equals -1 is x minus 1. So this is minus x minus 1 on, sorry, minus x plus 1 on x minus 1. It's minus 1 minus 1 on x minus 1. So this is actually minus x on x minus 1. So if we draw this function, this is going to give us This is a hyperbola. It is shifted by 1, so shifted down and across. So we end up with, we will have, the function would be like this, but it becomes negative, shifts across, you end up with something like this with asymptotes here and here. So you can see from, you can see that 1 is the asymptote, incidentally, and then the function sits over here. Between -1 and 1, this section of curve is continuous. And you can sort of see visually from a graph or modified version of a graph like this what those values are. You didn't need to do this though, right? You didn't need to use the graph to get the values, as long as you could identify safely that the function was continuous and you could look at limiting values on the endpoints. This is a perfectly fine way to do a question like this.